Okay, so hi guys, I just wanted to make this really quick video. Hopefully it's quick enough. um, over trig identities. So I want to do about 5 problems in this video, depending on how long it takes me. So basically, yeah, so I just want to go ahead and get started. You guys could give me 1 second. So the first one that I want to verify is 1. So 1 plus cotangent x over cotangent x equals sine of x plus cosine of x. So, this is the first one that I'm going to try to verify, and I'm going to do 5 of these. Hopefully they're long enough. I want to do some long ones and if they're short, I might do even more. But just enough to actually go over this. So, the first thing that you're going to want to know, you have to know your trig identities. Cotangent of x is equal to cosine of x over sine of x. So you're going to do cotangent x right here. So on top and bottom. So you have 1 plus cosine of x over sine of x over cosine of x over sine of x equals sine of x, and if it's already in terms of sine x and cosine x, you don't have to do anything. So equals sine of x plus cosine of x. This cannot be simplified any further. So anytime you have it in terms of cosecant x, tangent x, or cotangent x, or secant x, or any one of those, just make sure that you put it in terms of sine and cosine. So so now we want to do it so that it has the same denominator. So this top part here, we're going to say 1 over 1 plus cosine of x over sine of x. We want the same denominator, so we're going to do times sine of x times sine of x over cosine of x over sine of x. So we're going to simplify, and this is again equal to, and let me actually do like a little line here, a little curve to kind of follow along what we're doing. So equals sine of x plus cosine of x. Okay, so this basically becomes, so the top part is this whole thing. So then it becomes sine of x plus cosine of x over cosine of x, right? Over sine of x, excuse me. Over cosine of x over sine of x equals sine of x plus cosine of x. Okay, so now, and like I said, guys, if you don't know your trig identities, please have a table in front of you or have some kind of reference. I highly recommend that, because you have to know your trig identities for this. I would make flashcards, do whatever you need to make sure you have them right in front of you. So now we have sine of x, and I'm going to make it into a division of 2 fractions. Sine of x plus cosine of x over sine of x divided by cosine of x over sine of x equals sine of x plus cosine of x. So then this becomes, so let's see here. Give me a second, guys. Oh, I'm sorry. Oh my goodness, guys. Give me a second. I am so sorry. I meant to put over cotangent, or cosecant x. I am so sorry. This is supposed to be so... I meant to put over cosecant x, not cotangent. I am so sorry, guys. So this is cosecant x. Cosecant x is actually 1 over sine of x. It's still the same thing, but it's just the little... This part was turned into 1 over sine of x. That's cosecant x. I am so sorry, guys. So this becomes 1 over sine of x. So now this turns into... Because I was looking at it and I was like, wait a minute. So this then becomes sine of x plus cosine of x times, or I'm sorry, over sine of x times sine of x over 1. So now this is equal to sine of x plus cosine of x. So then these two cancel out, so we're left with sine of x plus cosine of x equals sine of x plus cosine of x. And we have verified the trig identities. So this is something that, yeah, so this is something that takes practice, right? We have to know our trig identities for this, and I know I might be going really fast, but I really want to make sure you guys understand. So just remember, cotangent x is cosine x over sine x. Cosecant x is 1 over sine of x, right? As long as you get it into terms of sine and cosine, everything else is algebraic. You have to know how to do your algebra really well. It's just like simplifying like complex fractions when we did x over y plus y over x over y minus y over x, something like that, right? It's just like doing that, but this time it's in terms of trig identities, and those trig identities are in terms of sine and cosine. The only ones that are not, well, the only ones that you can't really simplify any further are sine and cosine. I mean, you can if you do like, you know, like sine squared of x, you can do double angle identities, but we're not going to get into that for now. So the next one that I want to do, let's see here. And I'm actually going to do two things. So I'm going to do verifying as well as simplifying so that you guys understand how this is done. So this one is pretty easy. So cosine squared of x over 1 plus sine of x equals 1 minus sine of x. How is that true, right? This is 1 minus sine squared of theta, or sine of 1 minus sine squared of x over 1 plus sine of x equals 1 minus sine of x. Remember the Pythagorean identity? Oops. Sine squared of x plus cosine squared of x equals 1. So this becomes, so basically, cosine squared of x and sorry for my handwriting, guys. I think it's because I wasn't zoomed in. Cosine squared of x equals 1 minus sine squared of x. You're going to plug this in here, okay? So that is why I put here 1 minus sine squared of x. Remember that 1 minus u squared, or really, sorry about that, guys. My dog keeps barking. So a squared minus u squared equals a plus u times a minus u. Okay. So what does this mean for 1 minus sine squared of x, right? 1 minus sine squared of x is equal to 1 plus sine of x times 1 minus sine of x. So this becomes 1 plus sine of x times 1 minus sine of x over 1 plus sine of x equals 1 minus sine of x. So then we take the 1 plus sine of x out. This becomes 1 minus sine of x equals 1 minus sine of x. If you know your Pythagorean identities really, really, really well, this one is not really that complicated. And if you know how to factor, okay? So 2 things. You have to know the Pythagorean identity, cosine squared x plus sine squared x equals 1. You have to know how to manipulate it so that you can get cosine squared x by itself. And then you also have to know this rule, which is from algebra. I just did it in different letters, but it's the same thing. It's like a squared minus b squared equals a plus b times a minus b. It's the same thing. It's just different letters. The letter U, fun fact, the letter U you're going to be using a lot in calculus. So if you've seen your professors or your teachers use the letter U whenever they do like log base U of A or something, or log base A of U, or log base B of U, or U and V as well, UV, then that's why, because they use it later in calculus. But that's a fun fact. So now, we've done, how many have we done in this video? 2. So we're gonna do about 3 more. Let's see. Okay, so we have this next one. Now for this one, you're gonna have to know your even odd identities. So number 1, sine of negative theta equals negative sine of theta. Number 2, cosine of negative theta equals cosine theta. Notice that when it's sine, it's negative. When it's sine of negative theta, it's negative sine of theta. When it's cosine of negative theta, it's cosine of theta. So you have to be careful. Okay, really remember these 2. Okay. Oops. Sorry, guys. So, being that we have those 2, we have sine squared, and I'm going to rewrite it again, so give me a second. So, sine squared of negative theta, first of all, let's look at that one first, and I'm going to go really slowly. Right? This is basically this one here. I'm circling it in red because I'm writing it in red, right? So this is equal to negative, so it's gonna be sine of negative theta times sine of negative theta. Okay, this is gonna be negative sine of theta times negative sine of theta. This is gonna be equal to, sorry guys, give me a second. This is gonna be equal to sine squared of theta, okay? So then this one is going to be equal to, so, okay, so just to verify, if you go in your calculator, you can, or on Desmos, you can see, so let's see here, I just want to make sure it's right. If you go on Desmos on your phone, so sine squared of negative x is equal to sine of negative x times sine of negative x. Yes, it's true. So this is really equal to sine squared of theta. If we look at it, because like I said, it's negative sine of theta times negative sine of theta. So it's sine squared of theta, or sine squared of x, if you put it in terms of x. So really, that gets simplified to sine squared of x. So we have sine squared of x, right, for that first one. And then for the next one, cosine squared of negative theta, right? So this is equal to cosine of negative theta times cosine of negative theta. This is equal to cosine of theta, because cosine of negative theta is cosine theta. Remember? Right here. So right here. So we have cosine of theta times cosine of theta equals cosine squared of theta, right? So this then becomes, in and of itself, it becomes cosine of theta, right? So, or cosine squared of theta, excuse me. So now we can write it. So we can say sine squared of theta, and there's a reason why I'm going really slowly, guys, is so that you guys can understand what I'm doing. Because if I go really fast, nobody's gonna understand what I'm doing. So it's very, very critical for me to do this. Remember I said sine of negative theta is negative sine of theta. So we're gonna plug, basically we're gonna say for this one, let me use a different color. So we're gonna say negative sine of theta. And then minus, and then negative cosine, or I'm sorry, cosine of negative theta, which is this one right here, is gonna be cosine of theta. Because cosine of negative theta, like I said, is cosine of theta. So this in and of itself is supposed to be like it says in the trig identity, it is supposed to be equal to cosine of theta minus sine of theta. Okay? So let's write that down. So then this becomes sine squared of theta minus cosine squared of theta over negative the quantity sine of theta plus cosine of theta. This can be simplified. So, like I said before, let me write that down again. This can be simplified, like I said before, as cosine. So, let's see, hold on. So, we can use the difference of two squares to simplify the top. So we can say that that is equal to sine of theta plus cosine of theta times sine of theta minus cosine of theta. So it's all over negative the quantity sine of theta plus cosine of theta. This is equal to cosine of theta minus sine of theta. So then we cancel this out. We're left with a negative 1 here. So basically we have this. Don't forget your negative on the bottom. It's over negative 1, right? So what does that tell us? This is equal to cosine of theta minus sine of theta. So then this becomes negative sine of theta plus cosine of theta, because if you think about it, the way that you're going to do it is you have sine of theta over negative 1 minus cosine of theta over negative 1, or plus negative cosine of theta over negative 1. Right? This is equal to cosine of theta minus sine of theta, right? So then this becomes negative sine of theta plus cosine of theta equals cosine of theta minus sine of theta. Now how do we get it from this to this? How do we get it from this to this? How do we make this equal to this, right? Well, you can look at your terms. You have a cosine of theta right here, positive cosine of theta, and you also have a negative sine of theta right here. So basically, you can go ahead and put cosine of theta first. So you can put cosine of theta first, and then put negative sine of theta second. So then that'll be equal to cosine of theta minus sine of theta. Okay, this was a really long problem. Okay, I really tried my best to explain it in terms of like I said, in terms of like actually getting it to where it needs to be, we're gonna do one more, actually, because I don't want to make this video way too long. Let's do 1 minus cosine squared of x, or let's do it like this: 1 minus cosine squared x times 1 plus cotangent squared x equals 1. So the first thing that I'm gonna do is I'm gonna try to make 1 minus cosine squared x. So let's try to do this. So let's try to do and I don't know exactly what I did here that made it this way. I'll fix it later. I'm not sure what happened there. But basically this one here, so this problem right here, sorry guys, give me a second. I'm trying to see why it is the way it is. It's not supposed to be like this. It's supposed to be... Okay, so never mind. Give me a second, everybody. I'm gonna try to fix this. Okay, there we go. I think I fixed it. So, basically, so we're gonna make 1 minus cosine squared x into sine squared x, okay? So, the reason why I said that is because, remember, sine squared x, when I said all the way over here, so basically, if I did the opposite, so here, I'm gonna do it again. So, sine squared x plus cosine squared x equals 1. If I do the opposite, instead of subtracting sine squared x, I subtract cosine squared x, I get that sine squared x equals 1 minus cosine squared x. So that's what I'm going to put over here. Sine squared x times 1 plus cotangent squared x. Now, what is cotangent? We know that cotangent x is cosine of x over sine of x. Cotangent squared x equals cotangent x all squared. So basically, this becomes, if cotangent of x equals cosine of x over sine of x, then when we square it on both sides, this becomes cotangent squared x equals cosine squared x over sine squared x. So this becomes 1 plus cosine squared x over sine squared x. This is equal to 1, okay? So now, we're gonna just do distributive property. We have sine squared x because we distribute it, and then plus, we distribute this again, we have sine squared x cosine squared x over cosine, or I'm sorry, over sine squared x equals 1. This becomes sine squared x plus cosine, because cosine squared, so sine squared x gets canceled out. This becomes plus cosine squared x equals 1. 1 equals 1, so we have verified the trig identity, okay? So, I believe I've done enough. Let me actually just one more problem really quick, and then I will be done. Secant squared x minus 1, so secant squared theta. Let's use theta this time. Secant squared theta minus 1 over secant squared theta equals sine squared theta. Okay. So, basically, we can split this into two different fractions. We can say secant squared theta over secant theta minus 1 over secant, or I'm sorry, secant squared theta. Secant squared theta minus, so secant squared theta over secant squared theta minus 1 over secant squared theta equals sine squared theta. You have to know how to split it into two different fractions. It's like if I said x plus y over 4. This is x over 4 plus y over 4. It's the exact same thing. Or if I said x plus y over x. This is x over x plus y over x. It's the exact same thing. It's just in terms of trig. So this becomes so let's see here. This becomes 1. This becomes 1, so this one becomes 1. And then minus, and then this one, if you know that secant of theta equals 1 over cosine theta, you can solve for cosine theta. This becomes cosine theta secant theta equals 1. So then, to solve for cosine theta, we divide both sides by secant theta. This becomes cosine theta equals 1 over secant theta. So then this becomes, so if we have 1 over secant squared theta, this is really 1 over secant theta squared. So then this is equal to cosine squared theta. So this becomes, so really, 1 over secant squared theta is cosine squared theta, right? Equals sine squared theta. So then sine squared theta equals sine squared theta. Okay, guys. I am gonna stop it here because I feel like I've done enough. If anybody has any questions about all of this, please let me know. I know this was a pretty lengthy video, but I really wanted to make sure that we understand how to verify trig identities. I will probably make another video on how to simplify trig identities and where you're gonna have to actually simplify it as much as possible. So I may do another video on that, but yeah, this is the video that I decided to make, and I hope it helps. I hope that I somewhat made it a little bit more understandable. I know that I was going really, really fast, guys. If you want me to go slower, please let me know. I did try to really explain what I was doing in this video, because I know that these can be very complicated if you do not know your identities. This one especially this one, was a challenge. So if you did not understand this one, do not worry about it. It was a challenge problem. And as long as you understand what your trig identities are, that is why I wrote them down right here. Before I even did the problem, I wrote them down so that we can understand, okay, what exactly are we plugging in and where are we plugging it in. So with that being said, guys, thank you so much for watching. Please like, comment, and or subscribe. And with that being said, I also want whoever is watching, if you do watch this video, please make sure that you subscribe to my Discord channel, Ozzy's Math Tutoring, and like please follow me on there, or join the server, because I really need more people to join. But other than that, with that being said, guys, thank you so much for watching. And like I said, please like, comment, and or subscribe, and I will see you guys in the next